All right, so the second half of your section 6 notes are over extinctions, as you can see. So first we're going to talk about background extinctions, and those are typical, those are normal, and they're actually constant. So it's actually normal for organisms to go extinct because we know the environment is always changing and not everything can always keep up. So we're not really worried about background extinctions so much as mass extinctions, right? A mass extinction is when more than half of all of the existing species become extinct at once. So if we were to graph this to just kind of see what it looks like, right? If you have a extinction rate, right? You got this percent of extinctions at any given time over a certain period of time. There's almost always some extinctions, right? So it stays pretty low. It might fluctuate a little bit, but every once in a while, there's a mass extinction in which more than half of the species on the planet at any given time will become extinct. So if this is my 50% line, up here is more like 100%, right? I can get up above 50 and lots of organisms can go extinct at once. Usually these are linked to global events, right? You're talking about asteroids hitting the planet or great floods or something like that. But at any given time, there may be a lot of extinctions that happen at once. But then it should go right back down to more of a normal extinction rate, right? So that has happened many times over the existence of the planet. What we're concerned with mostly is that we seem to be on an uptick of extinctions at this time, right? So we're a little higher than normal, which means that if we extrapolate from there into the future, we may be approaching a mass extinction and we may even be causing that to a certain extent. Since human presence on this planet alone has changed the environments on this planet greatly, right? We might be forcing a mass extinction to occur much earlier than it needs to, right? So we're concerned with that to a certain extent. But extinctions aren't always a bad thing necessarily. Right? It depends on the context. So we have this patterns of evolution that we need to talk about as well. And when we're talking about patterns of evolution, we talk about this thing called punctuated equilibrium, right? And what that means is, again, over long periods of time, not much happens, right? So if I have species A, it just stays the same for a really long time because there's really not that much change going on. And even if it does change a little bit, it's usually small changes, very small changes, right? But then if something major does happen, if that global event that causes a mass extinction to occur may happen, right? All of a sudden, there's lots of new niches for that species A to exist in. There's a lot of new resources available for that species. And so, although those mass extinctions are a bad thing, right, they can also be a good thing because they're usually followed by this thing called adaptive radiation. So, this is kind of a two-part thing here. It's punctuated equilibrium, it's adaptive radiation. Adaptive radiation means that when one of those mass extinction events occurs, right, since there's so many more opportunities for any given species that's left, right, they may actually radiate into many different species from that original ancestor. So we actually think that mass extinctions are what help create new organisms because that's a chance for a species to evolve. So while 70% of the other organisms are going extinct, that provides opportunity for species A over here to turn into new species 1, 2, 3, 4, 5, right? But then after that point, extinction rates drop back down to normal, and so there's going to be a really long period of time where nothing really happens. And that's the punctuated equilibrium part, right? I have this long period of time over here where not much is happening, it's just kind of boring. And then all of a sudden, boom, right? There's this huge global event where there's lots of confusion and crazy chaos going on, right? But at the same time that a lot of species are going extinct, you're creating opportunities to make a lot of new species. So that adaptive radiation occurs during that time. But then Once that punctuation ends, once that craziness ends, things just go back to normal. And it repeats itself over and over again. So usually there's not much happening, then boom, all of a sudden lots of things happen all at once. Right? Things are going extinct, new species are arising, replacing those that are lost, but then it goes right back to that slow and steady change. So just kind of have that idea in the back of your head. But again, these mass extinctions that we always think of as bad things, they are actually good things in some contexts, because mass extinctions are usually followed by periods of adaptive radiation. And that's actually good for the species involved, because that one species just turned into 5, right? And that's how new species come about. If it wasn't for a mass extinction that killed the dinosaurs, humans couldn't exist, right? Because mammals took over when those dinosaurs died. And we had lots of new niches to fill. We had lots of opportunities and resources to use. So we adapted and evolved and changed into what we are today. So mass extinctions and adaptive radiation go hand in hand. They're all part of that punctuated equilibrium. Long periods of not much change followed by great change in short periods of time. And then long periods again where not much change happens.